Basically, that's what I wanted to show you. Whatever. We did determinants by core factor, and then we did it by row. We did it by row expansion. So row reduction. Then the last part. The last part is Cramer's rule. Cramer's rule. But before Cramer's rule, you need to know this. Determinant of Ka will be K and determinant of A, whereby n equal size of matrix. Oops. Square matrix. This matrix is a square matrix. Because you can't find the determinant of a matrix that is not square. So yeah. And then determinant of EB is equal to determinant of E times determinant of B. And the last one, determinant of A minus is equals to 1 over determinant of A. Just not this one. A determinant of A plus B is not equal to determinant of A plus determinant of B. It is not. If they ask you to find determinant of A plus B, you need to find A plus B first, because this doesn't apply. It's not true. And hopefully we can find questions that ask about this, man, because I didn't prepare questions for this, but I know there is one. I can't remember which assignment. But let me just finish this. If we have time after, we can find those questions. Basically, Cramer's rule, it's a very simple Cramer's rule. It's just a way of solving a Cramer's rule. Cramer's rule is a way, oh Lord, it's combining again with the internet. It's a way of solving for x, y, z. Let's make a quick example. Just looking for an example there. Yeah, let's say we have a system of equations like this. We've got 1, we've got x. We've got x plus 2, let's say x1, 2x3 is equal to 6. Then we've got minus 3x1 plus 4 x2 plus 6x3 is equals to 3, 0. And then we've got minus x1 minus 2x2 plus 3x3 is equal to 8. Using determinants. Again, we know how to solve for x, y, and z using the row reduction, this thing of adding columns and all of that. Then another way of solving for this is using Cramer's rule. If you know the determinants, if you know how to use determinants, if they say use Cramer's rule, you need to, let's write this thing. You need to, this is what you need to do. You need you need 4 matrices. The first one, we're gonna call it A. The first one being the matrix made by the coefficients. This 6 is not a coefficient because a coefficient is a number that comes before a letter. So here it will be A, 1, 0, 2, minus 3, 4, 6, minus 1, minus 2, and then 3. Then we need to find A1. A1 basically, you see in place, this is x1. Let me just put it here. X1, this is x2, this is x3. This is the row for x1. As you can see, all of them are x1s. These are x2s, then these are x3. So A1, you remove all the ones. In place of it, you put this answer. So 6, 38. Then you leave the rest. 0, 4, minus 2, 2, 6, 3. Then A2 will be cancel. This comes back, minus 3, minus 1. Now you remove this one. Put 6, 3, 0, 8. Then this, and then A3 will be the original 1 minus 3 minus 0, 4, minus 2. Then you replace this one with 6, 30, and then 8. Boom. Then once you have this, you find the determinants of all these matrices. But I doubt you will ask for all of them. Maybe you might say find x1 using Cramer's rule, something like that, because otherwise it will take forever. But you need to know, either way, you need to know how it's done, even if it's for 1. A, you always have to find the determinant of A using the methods that we described before. I'm just going to write the answer here. Determinant of A would be what? 44. Determinant of A would be 44. And then determinant of A1 will be at minus 40. And then that of A2 would be 72. And then that of A3 would be 152. 152. So this determinant, you can use one of those methods I showed you. There's 2 of them. You can either use one of them if you find a determinant and you are good to go. That means now once you have this, I think this is what they might give you. Maybe they might give you this, then probably give you is, then say find x, y, and z, x1, x2, and x3. Or they might just say x, y, z, still the same thing. The letters shouldn't scare you. Instead of putting x2 here, they might say this is y, and then the x3 here, they might say z. And in this case, x3. This one, x1, you look for the determinant of a1, which is minus 40. Everything gets divided by the determinant of a, which is 44. Everything will be divided by 44. And then x2, you look for a2, 72. x3, 152. So yeah, that's basically Cramer's rule. And we're done. We can maybe, I don't know if you have some questions, because I didn't prepare some questions on these things, exam questions. Just look on my Telegram, maybe I might find one. But if you have one close by, you know, on these things that we did so today, let me just look quickly. Yeah, I have this one. Let me just take you to my Telegram. Oh, where is this? Can you hear me? My internet seems to be, yeah, I knew it. Hello? Hello? I don't think you guys can hear me. My internet. Oh, we're still. Are we still here? My God, my internet.
Yes, we're still here.
Yeah. Luckily, we are done. Let me just show you quickly. Show you this question. Where is it? It doesn't want to show. I think this was, yeah. This question. Find the determinant of the following matrix by inspection. So what is this? What is the determinant of this matrix? Does anybody know? Lungile? Hello? Oh my God.
Hello?
Yeah, my internet is bad. Hey, my internet is bad. But what is the answer here? Find the determinant. Can you hear me?
Yes, we do.
Yeah, what's the answer here?
It's a -3.
Yeah, the answer is -3. Let's look for another one. Oh, this one is a good one. Suppose that A is a singular matrix.
This one is the tricky one. This one.
Sorry?
This one is so tricky.
It's so tricky, né?
Yeah.
Find a determinant. Choose the correct answer. Suppose that A is a singular matrix satisfying this. Okay, let's just quickly do it. We are given a squared, né? And then it's equal to -a. That's what they say.
Yes.
And then let's say they said find the determinant of A. This is what I would do. I would say the determinant of -a the determinant of -a, but they didn't give us enough information then. You know that the determinant of -a, which should be, because these two are equal, right? It must be equal to the determinant of a squared. right? And then, but the one on the left-hand side, we know it's gonna be, but they didn't give us enough information. Let me check.
They also give us that it's a singular. It's a singular.
Oh, a singular matrix. What is a singular matrix? It's a matrix that doesn't have an inverse, right?
Yeah.
So if it doesn't have an inverse, that means we cannot, the determinant is 0. Yeah, if it doesn't have an inverse, that means the determinant is 0. They give us that information. Let me cancel here. Let me check again. Suppose that A is a singular matrix satisfying A, okay? Choose the correct. Well, all of them, they have determinant of A. So actually, if it's singular, you don't even look, you need to understand what a singular matrix is. You don't even have to look at this. It's just a trick. If it's singular, that means singular implies that there's no inverse, which means the determinant of A is equal to 0. That's what it
Yeah.
means. So if we go back to the question, this is the correct answer.
Yeah.
You know why this is a correct answer? Because
Yeah.
whenever you have or, if one statement is true, because we've got two statements here, we've got determinant is equal to A, or determinant A is equal to -1. We have two statements, and if one of those two statements is true, it makes the whole combined statement true. This one is wrong, but because this one is correct, that means the whole statement is true. But if this was an and, basically this was trying to examine you on the word or and. If it's or, in order for the whole thing to be true, I mean, if it's and, for the whole thing to be true, both statements must be true. But if it's an or, only one statement is enough to make the whole statement true. I will find some solution. We did this one. Yeah, we did this one. We did something along these lines.
Yeah, but this one, it's you have to solve for C and
Yeah, you have to find B, but before you can find B, you need to solve for C. But C, it's easy because now you've got A here, and then
yeah.
I3 is basically it's this minus the identity matrix, and then you find the answer here. But the answer is going to be 3 by 3, and then
Yeah.
let me see. This is a 1, 2. This is a 3 by 2 multiplied by 3 by 3. Now there won't be an answer here. Let me just quickly show you why. You don't even need to solve this question. You just need to understand what's going on. Vt is equal to 3 minus 1, 3, 3, 1. Um, Sure. Oh, we have A. We have A is equal to 1, 0, minus 1, 1, minus 2, 0, minus 1, 0, 0, right? Then we've got C is equal to A minus I, 3, right? And then we've got
Yeah.
CBT is equals to 3 minus 3, 1, 0, minus 1. This question is actually simple. You don't even have to solve it. But even if you were to try and solve it, let's say I try to solve it here. Let's say I try to solve it. One, because maybe you don't see what I'm seeing, but let's just try and solve it, because I can already see that this question is not possible. Minus 1, 0, 0, 0, 1, 0, 0, 0, 1. 1 minus 1 is 0. 0 minus 0, then minus 1 minus 0. 1 minus 0 is 1, minus 2 minus 1 minus 3, 0 minus 0, minus 1 minus 0, 0 minus 0, 0 minus 1, right?
Yeah.
Now we can take it and put it here, right?
Yeah.
Before we do that, we're looking for B, right? They say solve for
Yeah.
B. So we need to get B by itself. So we know that, okay, I need to remove the C. And I showed you the other time how to remove the C.
Mhm.
This is what I need to do, right?
Yeah.
You see where this thing is? It's on this side. You just need to be careful. It's on this side. Yeah?
Yeah.
And then we have the 3 minus 1, 3, 3, 1, 0, minus 1. Actually, I think that's where the trick is. If you put it this side, it's probably not going to be, it's not going to be solvable. If you were to take this and put, I'll show you why. And then you've got a BT here. You've got a BT here. And then C minus 1. Let's just combine everything here. Minus 3, 9, 9, 3, 0, minus 3, right?
Yeah.
And then to get a B, we need to let's do this. We need to transpose, right?
Yeah.
Everything. Minus 3, 9, 9, 3, 0, minus 3. You need to transpose the answer here. That means B will be equal to. So now we need to find the inverse, right? And then multiply it to this with this. Let's just first check if it's possible. The inverse would be inverse of this. The inverse of this. Okay, the inverse of this would be 3 by 3, right? Then we are multiplying it by 1, 2, 3, 3 by 2. So it's possible because there's 2 are the same. But look at this. Look at this. Imagine we had taken this C minus 1. We didn't do it like this. We just put it on the other side. This, imagine if this is what we did. imagine we did something like this. -3, 9, 9, 3, 0, -3, C minus and everything T. We're gonna have a 3 by 2 multiplied by a 3 by 3. And look at this. If you had taken the C and put it this side, then there wasn't going to be any answer. You were just going to choose none of the above, which was going to be wrong. So this step is very important, this one. So in this case, the answer, let me just put it here. We just need to find you need to find C first. You still remember how to find an inverse, right?
3 by 3.
How do you find an inverse? It's very easy, right? You just have to, you have to find the inverse, basically. You have to find the inverse. But yeah, I'm not gonna do it now, but this is how you would do it. You find the inverse of this, and then you multiply the two, and then you take a transpose, you find your B. And your answer, what I can tell you is that the answer, let me just check. What I can tell you is that the answer, we say this is gonna be 3 by 3, and then 3 by 2.
3 by 2.
So our answer will be 3 by 2. So it's something like 1, 2, 3. Let's see if we have something like that then. Let me share the screen. Oh, you look at this. Actually, the answer is none of the above.
Yeah.
They didn't even have to find the inverse. You just needed to understand. They were testing if you know how to multiply matrices, yeah. If you know what you can expect, what you want, then it'll be easy. Because here you know that the answer must be a 3 by 2, not a 2 by 3. They were testing if you know how to multiply matrices and that you know how to remove the C. If you're taking this C and then you put, like, I think you know how to remove the C. You multiply it by C minus. But the next step is to make sure you multiply correctly on the other side. Imagine if you had taken this C minus and you put it somewhere here. It's going to make it wrong. If you put it somewhere here, it's going to be wrong. So basically, they're testing two things here. You know how to multiply matrices and you know how to remove this C. And yeah, let's see if there's another one. Let's check that. Find the general form of the complements. This question was wrong. There's something wrong with this question. I remember doing it many times. So after today, I don't know. Tomorrow is Tuesday. Maybe tomorrow we can. I don't know if should we do questions on the stuff that we just did today. Just to make sure we are comfortable, and then or we should do complex.
No, we should do questions. Then maybe we'll do complex numbers on Wednesday.
Yeah, that's what I thought as well. That's what I thought. So tomorrow we just do questions on the stuff we did today, and if we have time, we check other questions from the past lessons. So yeah, we're just about Yeah, we are done. Well, from each one is okay. Now we did something like this. Also did this. Oh yeah, there it is. Let A be the coefficient matrix of the system, right? A coefficient matrix. Remember, coefficient, it's number. It's a number that is next to a letter. In this case, you disregard this one. It will be 3, 4, 1, minus 2, 7, 1, 8, 1, 5. Now add the following cofactor entries of A. So you take your A, you make a matrix out of these coefficients. It's going to be 3 by 3. And then I showed you how to, they say you have to add this. 1, 2, 3. You have to add them. But before you can add them, you need to find what is the cofactor of 2, 1, cofactor 1, 3, cofactor 2, 3. Basically, we did this. We did this. And I'm sure you can find the answer here. And yeah, so we'll continue tomorrow then. We'll continue tomorrow. We'll do questions.